Am I visible and audible, bro? Oh, sorry. And it is written prep marathon Atlassian at the top. So if this document is visible, tell me in chat. Okay, great. So read this problem as we are doing from past sessions. You have to go through this problem and try to solve it, okay, on your own. And at the end, after some minutes, I'll guide you how to actually solve this problem. This is a very good problem. Whatever problem that we are going to discuss are from actual online assessment and of Atlassian. So you can expect the level to be good. And the topics that are going to be covered in this problems is amazing. Okay. Kickstarting with the first problem. I have put it into easy category. Looking at the problem statement, very good problem statement. Given an array of length n and q queries are being asked. Okay. Now in each query, two integer values are given to you, L and R, and you have to find number of values in that particular range inclusive. So for example, for this given array 1, 3, 3, 9, 10, 4, and for this query 1, comma 5, number of values which are inclusive in this range are 4, 1, 3, 3, 4. Okay. So we are looking for this. Now here are the constraints and about number of queries. So they can also be up to 10 to the power 5. Okay. Now go through this problem statement and try to come up with some solution. Okay. First step should be understanding the problem statement clearly. Like, okay. First step is to understand the problem statement clearly. You can share your logic or pseudocode in chat. Okay. Not one liners. So I'm looking for whole answer and all. Okay, logic of whole answer, not a single statement. Okay. First, extract the details that are given in problem. Okay. Whatever is given to you in problem, try to get maximum out of it. So, what details are given to you? I'll give you a slide and like how to get the details. So, look at the array. Array is not sorted in example. So, you can assume you're going to get mixed type of array. Sometimes you'll get sorted arrays, sometimes you'll get unsorted arrays. So do they change the value or the answer for any query? Like instead of this 1, 3, 3, 9, 10, 4, if your array is like this 1, 3, 3, 4, 9, 10. So for this array also, For this query 1 comma 5, answer will be same. So try to get information like this from question. Okay. I'll give you 2 more minutes. Okay, 3 more minutes before I'll share my explanation like how to approach this. Okay. Okay, Pragna gave one solution, but look at the constraints also. Those who are giving me brute force solution, is your brute force solution actually going to pass this? So first thing whenever you get a question is first is understanding the problem statement clearly. Once you understood it, you have to see the constraints also. Before coming to a final solution, see the constraints. Okay. For every query, if you will do a brute force, like go through the whole array and try to find which values are within that range. So it will take a linear time complexity for every query, and number of queries is 10 to the power 5, and your array can also be have 10 to the power 5 elements, so your time complexity will be n into q, or I can say q into n, so which will be up to 10 to the power 10 operation in worst case. And I told you in earlier session also, the number of operations that is allowed to avoid TLE is less than 10 to the power 8. In some cases, 10 to the power 8 operations also pass, like close to, but usually try to come up with a solution which takes less number of operations. Okay. So, Praharshini, sorry if I spelled your name wrong. So, she is saying sort the array, find the position of L if present or next value greater than L using binary search. Similarly, for R, if present or value less than R, subtract those index plus 1 number of values. Good job. Okay. So I got right approach. Okay. So from this hint, you should have thought of like sorting the array. I already told you whenever. Okay. Let me help you out with finding the solution of this. Okay. Okay. What is given? You are given an array A of length n, let us say. And there are q queries also, and format of queries is you are given two values L and R, and you have to find number of values inclusive in this range from array. So one example that we took is 1 3 3 9 10 4. 1 3 3 9 10 4. So this was our array, and first query was 1 comma 5. So answer for this was four elements. Okay, which is 1, 3, 3, and 4. Now, I told you one thing. Is the order really going to matter here? If my array is sorted, then also number of values will remain same. Okay, if my array is 1, 3, 3, 4, 9, 10, this is a sorted array. So here also number of values which are between 1 to 5 is 4 only, 1, 3, 3, and 4. So here the order is not important. Order of array is not important. And one thing that I am repeating again and writing here also, when order is not important, always sort the array. So your array is sorted 1, 3, 3, 4, 9, and 10. Okay. Because the reason for this is you don't know in future you might need to do some operations on array. Okay. And performing any operation on a sorted array and unsorted array has a huge difference. Okay, because in sorted array we can perform many operations very efficiently as compared to unsorted array. Like doing a binary search, we can only do in sorted array. Okay. Now coming to this, what we are given in range, in queries, we are given two values L and R, and we have to find inclusive values within this range. So for our query, it was 1 and 5. So what we can find the smallest index where the L going to be what? Greater or equal. Wait, I don't know why my screen sharing stopped. Is my screen visible? My screen is visible or not? Somebody is saying yes, somebody is saying no. Yes, 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 yes. Okay. So for this, what I want is I want all values which are going to be greater or equal to 1. Okay. For that, I am looking for smallest index. And using binary search, we can find these things because using binary search in sorted array, we can do all of these things. Finding smallest index, finding biggest index, finding this and that index based on condition. So that's why sorting an array is very useful when you want to perform some queries, like some operations on it in future. Okay, so here using binary search, I can find the smallest index where the element is going to be greater or equal to my L. Okay. So if I do a binary search here, what is the smallest index where the element is greater than equal to L? So my L is 1 and this is the smallest index. If I talk about index, let me write it 0, 1, 2, 3, 4, 5. Okay. So 0 is the smallest index in this case where the element present is greater or equal to my L. Okay, I am looking for values in this range. So this is my lower bound, 1. So I need to find values which are either equal or greater and where they should be at the smallest index possible. Okay. Now, what is the next thing? For this R, what I have to do? I have to find the last index. Okay. Last index where the value element present is less than equal to this value R. Okay, so I can say this the biggest index. So now my whole task is in this sorted array. So first thing I need to do is sort the array. And after sorting the array, I have to do two type of binary search. One binary search will give me smallest index, which satisfies this condition. Element present at that index is going to be greater than equal to L. And the second thing is, the second type of binary search is going to help me get the biggest index. Biggest index where the element is less than or equal to R. So in this case, for what is my R value? R value is 5. And what is the greatest index where the element present is less than equal to R? Okay, it is this value and the index is 3. So I got my smallest and biggest index. Smallest index is 0, biggest index is 3, and number of elements in this range will fall in this range. between 1 to 5. How many elements are there? I already told you. It is very simple. Bigger index minus smaller index plus 1. It is 3 minus 0 plus 1. I got it 4. And it is right also. A number of elements between these two indexes is 4. Okay. So, do you understood the logic for this? First, you need to pay attention on the thing that ordering is not important. Okay. Once ordering is not important, always sort the array. Once you are done with sorting, now coming to your queries, what you have to find? You have to find the smallest value which is going to be greater than equal to this L. Smallest index which satisfies this condition. And then you also need to find the greatest index which satisfies this condition. Okay. Now, do you understand the logic or not? Tell me in chat if you understood the logic for this problem. Am I audible or not? Okay, some students said that there is issue in my voice and all. So I want to confirm from others also. Is my voice clear and audible? Okay. Yeah, it is clear to everyone. So I think there is issue in your network. Okay. Okay. So I am sharing code for this. Is it still stuck? So I am sharing code for this. Okay. 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 There are mixed reactions from everyone. Okay. Now, here is the code for this. Very simple, not very hard and fancy because we have to implement binary search only. Okay. So we'll start from our main function. So what we are doing in main function? Okay. First, is this screen visible where my code, I have written a C++ code. Is it visible? Okay. Harshita is able to see this. What about others? Okay. So we are starting with because in every what I can say language, the we start from main function. Okay. So what we are doing here, we are taking input. Okay. What is the length of my array going to be? Okay. So in n, it is storing, we are storing the length of array. Then we are taking our array as input. Okay. Now after that, we are sorting. Why we are sorting? The reason for this is order of array is not important. And whenever this happens, we need to sort the array. Okay, because we can perform very good operations like efficient operations on sorted array. Now coming to queries, we have queries also, and the type of queries are it gives us two values of range L and R, left hand and right hand of a range, and we have to count number of values which are present in this particular range. Okay, now let us find the leftmost index or the smallest index which is greater than equal to L. Okay, which has value, sorry, not the index, which has value. So how to find the smallest index? Obviously normal binary search we are doing, so we need 3 points: starting point, ending point and middle point. Starting point will always be 0 as it is, because we also have to consider the first element. Ending point is going to be pointing at the last index. Midpoint is nothing but start plus end by 2. And what is n? N is nothing but length of our array. And in this answer, what is this answer? This is basically the final index that we are going to return. Why I am storing n minus 1? Because I am assuming this value present at the last point is going to be greater than equal to whatever value is given to me. So this is my assumption. Okay, we go with this assumption. And if we find any better, smaller index, we'll get that. Okay. Now, how this binary search start? This is basic condition for binary search. We'll continue till my start point is less than equal to end point for any binary search. Now, what I am checking for? If my middle value is greater or equal to the value I am looking for, if my middle value is greater or equal to the value I am looking for, then I'll consider that index. So I will update, I will store the minimum value in my answer. Answer is nothing but it is storing the minimum index where, or the smallest index where the value is greater or equal to this past value val. Okay. So I'm considering the value, and next thing is I'm searching for smaller index. Okay, let me explain it here also. So if this is the range 1, 2, and so on, and then there is mid value and so on the last index. So I'll call this start. So what I am able to see that my mid index is satisfying the condition. So what I did, I have considered this mid index. Now, is there any point looking for bigger indexes? There is no point, because I'm looking for the smallest index in this case. So I will update my endpoint to this, because now I want to search for smaller index than mid, because mid is already satisfying my condition. Okay. So that's why I'm updating my endpoint, because I am searching for smaller index if possible. I have considered current mid value. Okay. Srija, you'll get. So we already shared with the student. If you have registered with the form, like before joining the session, if you have filled the form, you will get the link and all. Okay. We'll also share the form in between also. Just fill it. We'll share everything. Okay, no more questions related to this. We'll ask to you at the very end also. Let us finish this session first. Okay, if middle value is not able to satisfy this condition, my array is sorted. So current value is not greater or equal. So in this case, what I need to say is, so if my middle value is not greater or equal to current value, it means all value to left of it are also going to be smaller than mid. So they will also not satisfy the condition. So in this way, we need to update our start point. Okay. So here we are updating our start point to mid plus 1, because mid is not satisfying. So it makes sense that all value from start to mid will not satisfy. That's why we are updating our start point, because now we will search in this range. That's how binary search works. Okay. Then we are finding new mid value based on start and end. And again, this will go on and on. This is basic binary search. And with help of this, what we are going to achieve, we are going to get smallest index where the value present is going to be greater than equal to L. And we have sent L here. So this is our L, leftmost point or left part of range. Okay. Now for right or the biggest index, what we have to do, we have to find the greatest index which is less than equal to this value. So we have to do slight changes only. Everything will remain same. So if there is some mid value which satisfies this condition, so in that case we look for much higher value, because in this case we are looking for greatest index that is possible, which satisfies this index. Okay, so these are the basic differences that we have to do. Basic binary search we implemented. This is for finding smallest index which is greater than equal to L value, and this is the greatest index which is less than equal to the right value. Okay. Okay, so with the help of that, we can find the smallest and greatest indexes. Now, if left is greater than right, then it is an invalid range that we got. In that case, we have to print this zero. Okay, so there can be cases when we have zero element in range. Okay, we'll see those cases also. And if it is a valid range, and then number of elements is right minus left plus one. Okay, so is this clear or not? Please tell me. Is this problem clear, or you have any doubt? You can tell that also. Before we move to next problem, if it is clear, please tell yes. If it is not clear, please tell the doubt. Okay. Roll the program once. Array, just understand the logic. Okay. Here is the program. This is basic binary search conditions here. Then we are looking for what? We are looking for, this is for finding smallest index where value present is greater than equal to L. So whenever this mid is satisfying that condition, we'll look for more smaller value because our goal is to find the smallest index. So in this way, you can also find the biggest index also. There the condition will change. Now you are looking for value which is less than equal to R. Okay. And if some mid value satisfies the condition, you'll update the start point because your goal is to find biggest. So you'll move right side. Okay, for finding biggest, right of mid. So that is what you are doing. Here, okay, why this statement I have written? Because I want to find the minimum index. I started with this assumption that my last value is all going to be greater than equal to L. Last value is the biggest value. So it is my assumption that the biggest value will be greater than equal to L. That's why I started with this value. And if I find a smaller value, I'll update my answer with that because I'm looking for smallest index which is greater than equal to L. Okay, don't get like confused with this. Since my mid is changing to lower side, so this is also right. Okay, but usually like general, it's my habit of getting that way, so that's why if you put the mid, you'll get the same answer because your mid value is also decreasing. Okay, if you're finding, if this condition is satisfied now, then you'll reduce your mid value because your end point is reducing. So answer equal to mid, this will also give you the right answer. Here also you can say answer equal to mid because here we are assuming the smallest value. The value present at 0th index is going to be smaller than R. Okay, so this is our assumption. So if you write answer equal to mid, this is also right. This will also give you right answer. Okay. Okay. Anyone have any other doubt before we move on to next problem? Please tell me. I mean, asking question is a very good habit. Okay. If you are getting doubt, it means you are trying. Okay, since no one have any doubt, I'm moving on to next problem. So this is done. Now we are getting to this next problem. Read this problem carefully. I am assuming everyone is trying. Okay, let me put it here. Yeah. So this is a very great problem. This kind of problems repeat very much, not just to Atlassian and all, very frequent in lead code contest and other company online test and online assessment rounds. These kind of problems repeat a lot. Okay. So this is what I can say is a standard problem. Okay. So just try it. So problem statement is there are n balls placed in one dimensional axis with each of them moving with same speed. Okay. So there are multiple balls in one line that we understand till now, and they are moving with same speed. Now, direction I represent the direction in which the ith ball is moving. Okay. So there are directions also which ball is moving in which direction. It is given in array direction, and direction I tells about that. If minus 1 meaning it is moving to the left. So minus 1, if the value of direction I is minus 1, it means ball is moving to left. And if the value is 1, it means ball is moving to right. Okay, very simple. Now, the definition in this is simple. Okay. The strength of ith ball is described by strength I. Okay, so we are also given the strength of balls. If two balls collide, the one with higher strength destroys the smaller one. If both have the same strength, both are destroyed. Okay. Return a list of indices of the ball that remain after all the collision have occurred in ascending order. Okay. So I hope you all understood. So collision is possible. Suppose one is moving in right direction, one is moving in left direction. So obviously there is going to be collision. So if this ball, left ball, a ball which is moving in right direction and this ball moving in left direction, on collision, how they behave, the one who is having bigger strength will survive. So suppose this ball moving to left is having more strength, then after collision, this will still continue to move to left. Okay, this will survive. Okay, we need to return the indices of balls that will remain after all the collisions. And yeah, one more thing is given if both have same strength, both will get destroyed. Harika. Okay, nice, nice. So I got one answer from someone who have already solved. So this is a standard problem. Let's see how many of you are able to solve this. Sorry, sorry. Okay, I got one more response. Find the ball with unique maximum strength in left and similarly for right, find their indices. Okay, Prashini, can you please elaborate your answer? Okay, so this type of collision problems are very common and all. Okay, so let us discuss some cases of collision, how this collision is actually okay. Okay, so there are multiple balls. So this is a 1D line. Suppose what is happening here is balls are moving. So we have many type of balls. So they have same. Okay, suppose this is moving right, this is moving right, this is moving right, this is moving right, this is moving left, this is moving left. Okay, so how it is given, their direction is given. So for right it is 1 and for left it is minus. Now obviously if there is a one ball which is moving to right and one ball which is moving to left, there is a collision possible. Okay, so now what there are three cases of collision. Basically there are two cases. So one is if two balls that are colliding have same strength. Okay, first condition for collision is different directions. Only balls having different directions can collide. And that also if a ball, first ball is moving to right and next ball is moving to left. If there is a ball, first ball moving to left, second ball moving to right, there is no collision. So this is the case for collision. Okay, if they have same strength, so after collision, both will destroy. So here, assuming these two are having same strength, what will happen at some point? They will collide and they will get destroyed. So these two will get destroyed. So let us remove them. What will happen after that? Okay, we still have two balls. So now this is moving to right, this is moving to left. Okay, so they will collide at some point. But what I can see is this ball is having greater strength than this. So it will destroy this ball. So this ball will be destroyed and it will keep moving to right. Now there is no ball to its right which is going to collide with it. So it will remain after all the collisions. Now what about this? They will also remain because there is no ball left which is moving to left or which is going to collide. So for this, index 0, 1 and 2 is going to be our answer. Now generally in collision problem or whenever there is some problem like we are moving to right or doing some operation going right where we are getting plus 1 points and left we are getting minus 1 points. If there are problem like this, so in that case you have to use stack. Okay, you have to use stack. Here what you can do is, so these were the cases. What is happening if, how we can use stack? If a ball is moving to right, if a ball is moving to right direction, we can push them in our stack. Okay, and if the ball is moving in left direction, what we can do is we can compare with the value present at the top of stack because that is the first ball which will do collision with this ball. Okay, so here why stack? The reason is if there are multiple balls which are moving right. So this is the first ball, second ball, third ball, and this is the last ball. And there is one ball after this which is moving to left. So this ball which is moving to left will collide with which ball? It is going to collide with the last ball. So last ball, first collision. Do you got the hint from here? What is the property that stack is based on? It is based on last in, first out. What we are doing here, last ball, first collision. Last ball which is moving to right will collide with first ball after that, first ball moving to left. Okay, after this point. You got it? So from here you can get a hint of using stack. And generally in this problem, stack is very efficient. because we know that collision is going to be with the last right ball which was moving right, and to get the last ball quickly we can use stack because the top element stores that. Okay, the last or the last ball which was moving right, which will be at the top of stack, so I can get from there. Now what is the logic for solving these problems, how we actually do that? So there are few steps. Now if ball is moving right, we'll push them in stack. Ball is moving right, we'll push them in stack. Okay, so these are standard approaches for solving this type of problem. I'll tell you a few more problems which are solved using same algorithms and all. And the next thing is, if you found a ball which is moving left, ball which is moving left, now it can do collision with a ball moving right. Okay, so for collision, what is required? A ball which is moving right. Okay, and which is present before this. Before this. Okay, so for collision, what you need? You need one ball present in your stack. At least one ball should be present in your stack now, which was moving right. That will tell you, okay, so there is a right ball which is before this ball, and we can have a collision. If your stack is empty, it means there is no ball which is moving right before this, so there is going to be no collision. No collision if stack is empty. So example of this you can take like this. Suppose this ball is moving left, this is right, this is left, this is right, this is left. Okay. Now you got to this ball which is moving left. Okay. For collision, what you need? You need a ball before this ball which is going to move right. Okay. But your stack is empty. It states that, okay, there is no ball before this which is moving right. Okay. No ball left also you can say. Because in collision, there can be some situation when two balls collided and both explode. So if there is no ball, no collision. So this will go out safely. Okay, now there is no ball with which this ball can collide. Okay, now coming to this, these two balls will collide. Obviously, this ball will be in my stack because whenever you found a ball with which is going in right direction, you'll push them in your stack. So index of this ball I'll push. So index 2 is present here. Sorry, 1. Now, when I found a ball which is moving left, I'll check. Is my stack empty? No, it is not empty. So collision will occur. Now, how the collision will work, like react, it depends on their strength. So we'll compare the strength now. If strength of this ball, so strength of ball present at top of stack. If strength of this ball is greater than the strength of current ball, strength of ith ball, I will say, because we are at ith index. So what will happen? This ball will explode because this ball is more powerful, have more strength. So this ball will explode. Okay. If they have same strength, if these two are equal, then both ball will explode, and we'll do changes according to that. Okay. So let us continue this algorithm. If ball is moving right, you'll put in stack. If ball is moving left, and if it is empty, then there is no collision. If it is not empty, so there is going to be collision. And after collision also, so suppose let us take few example. What will happen after collision? So there are bunch of balls. So these two balls are moving right. This one ball is moving left. Now first collision will occur between these two balls. Obviously, this is the last ball moving right. This is the first ball moving left. So collision will be between them, and strength of this ball is less, so this will explode it. After this, what will happen? It will not stop here. Again, this ball will be moving in left direction, and this ball is moving in right direction. So we will have second collision also. So these all will keep colliding, okay, until either it is destroyed or there is no more ball left for collision. So here also collision will occur, and this ball has smaller strength. So this will destroyed. At the end, we are left out with this ball only. Okay. So in this way, we use stack for this. If ball is moving right, we push them in stack. If ball is moving left, so there are two chances. For one is for collision, one is for not collision. For not collision, what is the chance? Or what is the condition? My stack is empty. So there is no ball which is left of current ball or before this current ball which is moving to right. Okay. So this is chance of no collision. Now condition for collision is like this. If I talk to you about condition of collision, what will happen in collision? So what are the cases? So collision will keep on occurring if strength of my ith ball, current ball, is what? Greater than the strength of greater or equal to strength of top ball present at top of stack. So in this case, collision will occur. And what I have to do, if they have same strength, so obviously I need a marker here where I'll check about this condition. So if strength of ith ball is greater than strength of top ball, so in this case, this top ball will explode because my ith ball is more powerful. So exploding means it is removed. So I'll pop this element from my stack. Okay, this ball is demolished. So I'll remove it. If this is not happening, then what I have to do? I have to make both ball explode because that is the second condition. Either the strength is greater of ith ball or it is equal. So this is case of strength. When strength is greater, I'll explode, make the top ball explode. So that is by removing it. Else, what will happen? Top ball will explode and I'll come out of loop also. F equal to 1. I'll mark this here and come out of the loop. Okay. Why I have marked, we'll see. And I have to come out of the loop because no more collision is possible because ith ball is destroyed. Now let me show code for this. And there I'll explain why we are doing this. Okay. Now before that, so let us take this test case. So let us take this test case. Let me share the code also. So here is the test case. Okay. So the test case is like this. There are six balls. And first lines tell you about the strength of those balls. Okay, I'm assuming my this code editor ID is visible where I'm sharing this test case and all. So what is happening here? So for this test case, these are number of balls and these are their strength and this is their direction. Now what is happening? 7 is moving right. Okay, we'll push that in my stack. So my stack have 7 at the moment. Now I'll go to next ball, which is 6. 6 is also moving in right direction. So I'll push that into my stack. You can assume this last element to be present at the top of stack. Okay. Now what is happening? When I go to this index, next index, this is happening. Yes. So when I go to next index, the strength of that ball is 3 and it is moving in left direction. So here the collision is possible. Now what is the result of collision? Since the top ball has more power is more having more strength, so it will destroy this ball. Okay. So I will have no change in my stack. These two balls will keep on moving in right direction. Okay, what is next thing? Again, I got a new ball, which is ball number two. So I'll add that to my stack. Now, what is happening? Since it is also moving right, no need to do any collision. But when I move to this place, this ball is moving left and it has strength 11. So collision is possible. First collision is going to be between 11 and 2. So we have a ball which is moving in right direction with strength 2 and a ball moving in left direction with strength 11. Obviously, on collision, this ball moving right with 2 will destroy it. So I will remove this. Again, next ball is 6, which is moving in right direction. Now I have a ball of strength 11, which is moving in left direction. Now what is happening? 6 is having less power, so it will be destroyed. So 6 is also over. Now there is one more ball of strength 7. Now what is happening? So this the collision is going to happen and the ball. So ball moving left is having more strength, so it will destroy this 7 also. Now there are no more balls. So this ball with strength 11 moving in left direction will survive all the collisions. Okay, because there is no ball left, so no collision will occur. Okay, after that, I'll go to my next wall, which is moving right. So after this, what will happen? This will happen. So at the end of every collision and performing every collision, my stack have one ball, which is 9, and index of this ball. I'll not store the strength, I'll store the indexes. Here, for your understanding, I have put it the strength, but in reality, I'll push the indexes because we have to find indexes. So index of this going to be, it is 5. And let me write indexes here. 0, 1, 0, 1. Okay. So stack will do something like this. So these all operation will happen. So now in my answer array, this fourth ball was not destroyed. And this fifth ball was also no destroyed because they will not take part in any collision. So at the end, the answer is 4, comma 5. Okay. Now coming to code of this. Okay. So don't, one more thing that I said, whenever you face a problem like this. So as we saw the in examples, what is happening? The last ball which was moving right will collide with the first ball. After this, the first ball which will move to left. Okay, so this gave us the hint of last in first out data structure, which is stack. Okay, what we are doing in this program, first we are taking input of length of arrays that we are going to have. In next line, what we are doing, we are getting the array itself, strength array. Okay, what is the strength of every ball? Ith strength I will tell me, it is the strength of ith ball. Now this is direction. This will tell me direction of ith ball, okay, where it is moving. We have two values only. -1 means it is moving in left direction, +1 means it is moving in right direction. Okay, now what we are doing in balls, so we have created a stack name balls. You will push those balls indexes which are moving in right direction. Okay, and this index array will store all the indexes. Okay, which will survive at the very end after all the collisions. Now, what we are doing, we are traversing through the array, going through the array. Okay, see this part very closely. Okay, because there might be some errors here that I am expecting you to point out what is wrong in this code. We are missing something in this code that you have to tell me. If you understood the logic and all, you will be able to find this. Okay. Now here what is happening? I am going through every element. If direction is minus one means ball is moving left. Okay, so there are chances of collision because if ball was moving right, I will just push in my stack. So else part is nothing but adding the index of ball to your stack because this ball is moving right. Okay, nothing you have to do here. Now, for collision, first condition is there need to be some ball before this which is moving right. So in that case, your stack will not be empty. Here the stack is empty. It means there is no ball with which your ith ball will collide. Okay, so no collision. This is the condition. My stack is empty. Now, if there are some balls which are moving to right direction and my current ball is moving in left direction, so there are chances of collision. Collision will occur. Now, what will happen in collision? So, first collision will be with the top or the last ball which was moving right. Okay, so TIDX is nothing but index of top ball which is present at balls.top. Okay. Top function is in stack, which gets us the value present at top of stack. Now, if my strength of my current ball is greater than strength of this ball, then this top ball will explode. What I'm saying, ith ball which is moving left is having more power, more strength than the ball which is present at top of my stack. So obviously this ball will explode. So explode means this will be removed. You got it? Else what I am saying is break means come out of the loop. Current ball is going to be destroyed. Now, do tell me what is wrong here. Please point out thing that I have done wrong here. There is something wrong in this code in this part only. I have pointed out everything. You need to tell me what is wrong here. Okay. So what's his name? Karthik. Pop equal strength. Okay, we need to take care of equal strength also. In case both balls are having equal strength, both will explode. Here we have covered which case? We have covered two cases. If ball moving left is greater than, have higher power than this ball moving right, then right will explode. Okay. If right is having more power, this will explode. So we have covered these things, but we have not covered the case when both have equal strength. So we have to take care of that. So for that, we can do is we can use a flag. This will tell us, is there a case where both balls did a collision and exploded? So that is a case here we need to add. If strength of my current ball is equal to strength of the top ball. If this is happening, obviously the top ball will explode and I'll mark this as 1 and come out of the loop. Okay. Okay. Why I have flagged this, I'll tell you right now. Because when I'm coming out of the loop, what I'm checking, if my stack is empty, it means this ball which was moving left has destroyed all balls which were moving to my right. So I'm left out with this ball. This ball will remain safe. So I'm pushing that in my IDX index array, which I need to print at the end, which store all the indexes of balls which will remain safe after all the collisions. So I have not considered the case if there is only one ball moving right, only one ball moving left, and both collided and both destroyed. In this case also, stack will be empty. You can assume a case like only one ball is present in stack and my current ball is having same strength. So in this case, after collision, this ball is destroyed, so I'm removing it from stack. Okay, this is the line ball dot pop. So I'm removing. So stack is becoming empty. So I need to take care of that case. Okay, so here I also need to say that if f remains 0, f remains 0 means I have not found any collision where my current ball is destroyed. If these two conditions are matched, then only my ball moving to left remains. Okay, then I can add it to my index array. Is it clear? Now I have covered everything. Okay, after this, what we have to do? After this, there might be some indexes left in my stack. So those indexes are indexes of balls which are moving right, and either they have destroyed all the left balls moving left, or there is no ball left for collision. So I need to take this balls also. I'll take their indexes and remove from my stack to get other indexes. After this, I have to sort this. Okay. Reason I'm sorting because we want in increasing order, indexes in increasing order. To get that, we are doing this. So if I run this code for this test case, expected is 4, 5. So after changes, let us see we are getting this or not. Yeah, we are getting this. So our code is right. Now, please tell me, do anyone have any doubt you understood or not? Please tell me. This is one of standard problems which repeats a lot. The logic is not very hard, but you have to identify the problem. Identifying it is a bit harder. Okay. If you understood, please tell yes in chat. Or if you have any doubt, you can also tell me your doubt. Okay. I'm waiting for your responses. Okay, so the session looks to be very dead because you are not participating. May I know the reason you are not able to understand? You can tell me which part you are unable to understand. Not understand. Okay, I can repeat that part for you. If you understood, then tell me in chat yes or no, something like that. Can you explain in short? Okay, I'm explaining one more time, last time, then we'll move to next question because you're not responding. Okay. This session is for you guys, okay? And you are not taking it seriously. So, what is the logic here? There are multiple balls. They are moving in right direction. Okay. If there are multiple balls which are moving in right direction, are they going to collide anytime? No, they will never collide because everyone is having same speed. Okay. So if balls are moving in same direction, if suppose there are three balls moving in left or four balls in left, there are bunch of balls which are moving in same direction, they will not collide with each other because they are having same speed. Now collision will occur only with when there is a ball which is going to right and there is a ball after this which is going to left. We have collision in this case only. Okay. Now what is happening here? For collision, this is the only state. If there is a ball which is moving to left and after this there is a ball which is moving to right, the collision is not possible. Okay. So you understood the state of collision. Now, what are the cases of collision? Why this is a stack problem? So it is a stack problem because if there are multiple balls which are moving to right, the first ball which will move to left will collide with the last ball which was moving to right before this point. Before this point, it will collide with the first remaining ball, I will say, because in collision both balls can destroy also. Okay, so this collision is occurring between last ball before this point which was moving to right with the first ball moving to left after this point. Okay. So this gives us hint of using a data structure known as LIFO, or which uses LIFO property, last in first out, and stack is used for that. Okay. So we are going to use stack. And what is the condition, how approach operation we are going to perform? If a ball is moving to right, we'll simply push them in our stack. Push in stack if the ball is moving to right. And whenever you found a ball which is moving to left, in that case collision is possible. Will it happen? It depends on stack is empty or not. If the stack is empty, so there is no ball with whom this ball can collide. Okay. So it is a condition of no collision. Okay. If there are some balls, obviously collision will occur. Now, what are the conditions? So this is my current ball moving to left, and these are the balls which are in my stack. So first, if these two are colliding, so there are three scenarios. Strength of this ball is greater than strength of ball which is present at top of stack. In this case, what will happen? This ball will get destroyed. Destroyed means this will be removed. So I'll do the pop operation in my stack. Okay. So this is case one. What is case two? When both balls, this ball moving to left, this ball moving to right, are having same strength. Okay. In this case, collision will happen and both of them will explode. So in this case, I'll remove this ball from my stack and I'll not take this ball in my index array, like index of this ball in my array, because this ball is getting destroyed. This will not remain after all collisions. Okay, so this is case 2. Now what is case 3? Just a second. So case 3 is when the current ball which is moving to left is having lesser strength than the ball present at top of my stack index, okay, at that particular index. So in this case my current ball will be destroyed, nothing will happen to my stack. I don't need to pop the index of element present at top. Okay, so these are the three cases that we need to take care of. These are the three cases. Okay, if you are able to take care of all the three cases, then your job is done. At the end, all in balls which are remaining, you will return those indexes. Okay, now is it clear? So now I explained in short also. Now similar kind of problems, let me tell you, like similar kind of problems are valid parenthesis. There is parenthesis problem. Okay, and I already told you before start of this problem, if you find something like this, in one step you go to right, in if there is another operation in that you are going to left. So you are doing this kind of things. Okay, obviously there are huge chances that you have to use stack in that problem. So this problem is very famous, valid parenthesis, where you have to check if given set of parentheses, like string of parentheses, is valid or not. So valid in the sense, for every opening node there is a closing node. Sorry, closing bracket, not node. If this condition satisfies, you can tell the string is valid. Okay, so this is very famous problem. So this is also of same type. Now with all this done, let us move on to next problem. Okay. So try this problem. This is another type of problem, one of my favorites. I love this kind of problems, and very useful one. Okay, here we'll be using some concepts. Okay, I'll tell once you try. Okay, first try it on your own. This is a very good problem, bookmark it. Okay, we'll share everything. Okay, whatever my we are doing here, I'll be sharing every part of it, be it questions, code, and recording also. Make sure you're joined to the Telegram group, and whatever form is shared to you, just fill those forms. Okay. Now try this problem. MEX. MEX is minimum excluded. It is short form. MEX is short form of minimum excluded. So you are given an array ARR. So let us bold this out. Containing n non-negative numbers. So this is very important because in MEX problems we don't have negative values. Okay, non-negative integers and an element x. Okay, so element x is also given. In one operation, x can be added or subtracted. So focus on this line. So in one operation, you can add or subtract this value x from any element in array. Okay. Now MEX it told you about MEX. What is MEX? So MEX is an array defined as smallest non-negative number which is not present. So minimum excluded. So minimum number which is excluded from the array. So given this thing, this array 0, 1, 1, 3, here you are not seeing 2. You have to deal with non-negative numbers only, and the number which is not included, the minimum number which is not included, or the minimum excluded number, you we call that MEX of that array. So MEX of this array is 2 because 2 is not present. Similarly, MEX of 1 to 4 is 0 because non-negative means 0 should be there. So what you have to do, find the maximum possible MEX of array that can be achieved. So this is your goal by doing above operation any number of times. What is the operation? X can be added or subtracted. Okay, give it a try. Very wonderful problem. Take the example. Okay, with example you can get some slight hint. Okay, you have two ones present there, and you can get 4 from it. Like 1 plus 3 give you 4. So in this way you are able to increase the MEX. So what is the MEX of this array? MEX of this array is 4 because 0 is present, 1 is present, 2 is present, 3 is present, 4 is not present. MEX of this is 4. Now the value of x for this question is 3. With the help of this x, what I can do is I can add this x here and it will give me 4. Okay. Now after this my array looks like this. 0, 4, 1, 2, 1, 3. So now I have 0, 1, 2, 3, and 4. So which is the value which is not present here? That is 5. So max of this is 5. So I have increased it with this operation. Earlier it was 4. Okay. One hint that I will give here is for this array, answer is 5. Okay. 0, 1, 2, 1, 3, and x value is 3. Okay. Suppose if my array was like this 0, 1, 2, 1, 0, then what is the MEX that I can have? The maximum value of MEX that I can have after performing operations. Can you tell? Just tell me in chat. What is the maximum MEX I can get after performing operation on this array? 0, 1, 2, 1, 0. In one operation, you know what you have to do. If X value is 3, you can add it to any number or subtract it to any number of array. And you can perform that operation any number of times. Okay. Now just looking at this array, what is the maximum MEX that is possible? Don't get scared with the name MEX. MEX is the first value which is missing. You start from 0 and you keep incrementing. 0 is present, okay. 1 is present, okay. 2 is present, okay. 3, oh, 3 is not present. So 3 is MEX. Okay, I got 6, 5, 4. Multiple answers for this. Okay, so the correct answer for this is 5 only. Okay, what you can do is this array can be changed to this 0 it is. Now you can add 3 to this first one, you can get 4. Now 2 will remain as it is, then 1 again. Now you can add 3 here. So to get this array, you got my point. So you have added this x here and here to achieve this array. And MEX of this array is 5. So right answer for this is 5. Okay. It is given you can perform the operation multiple times. So what is common between this 0 and this 3? I'm giving hint. Okay. Try to get that hint. Okay. Go in reverse order. From this array to your right, how to get this array 0, 1, 2, 1, 0? You are given array 0, 4, 2, 1, 3. Let me use my pen and PPT. Okay. So what I am saying, what is given to you? 0, 4, 1, 2, and 3 is given. So from this array, how to get this 0, 1, 1, 2, 0? How to get this array? Because we already saw from this array, I can generate this array. What is the relation between this array? How to get this array from this array? So you are given this array and you want to get this array. What is the relation? Here it is 3 and from 3 I need 0. Okay, x is also mentioned to be 3. For this value of x, how to get this particular array from this array? Subtract is not partially correct, I would say. Partially correct. From subtracting, I can get that. Obviously, we are doing subtracting and all. Right answer for this is using divide and take reminder. Good job, Gauri. Modulo operation, guys. Modulo operation. So, what are allowed? So, suppose there are 1, 1, 1, and 1. So, these ones are given to you. And the value of x is 3. So, I have 1. In this one, I can add this 3 to get 4. Here I can add 3 two times to get 7. Here I can add 3 three times to get 10. So my final array is something like this. Let me write it here. 1, 1, 4, 7, 10. So it is possible to get this array with this x using the operation that is given to me or that is allowed to me in my question. So what these all are related like that. So 1 mod 3 is 1, 4 mod 3 is 1, 7 mod 3 is 1, 10 mod 3 is 1. Okay. So if there are four ones, so first I can get one to generate 1. From next one I can generate 4. From next one I can generate 7. From next one I can generate 10. So here what is the hint? 0. So what was the array? 0, 1, 2, 1, 3. Initially this was given and I was able to use 1, 1. Okay. So first I look for 0. Is it present in my array? Okay, yes. Next 1. 1 is present in my array. Next 2 is present. Next 3 is present. Is 4 present? No, 4 is not present. Now what will I check? Okay, 4 mod x is present. 4 mod x is present or not? So 4 mod x, because x is 3, 4 mod 3 is 1. So is there one present which is extra? Extra one present? Yes, that extra one is present. So I can use this one for getting 4. Now there is no more ones present. Okay. So I got 4 also. Next time, what is it? 5 is there. For getting 5, is there 5 present? I'll check. No. Now 5 mod 3, which is 2. 2 is present, which is extra. No. All elements are utilized, so that's why the answer for this is 5. So here we have to do in this type of problems, what we have to do is first we can convert our given array to their extreme initial state, which is so from 0, 1, 1 to 0. From this array, for this value of x, I can get 0, 4, 1, 2, and 3. You got it? So this is extreme initial stage. From this array, I can get this array. So let us convert all elements into this extreme things. Okay, then we will try to get the values. We'll start from 0. We'll check, okay, we can get 0. Is 0 present? Okay. Then we'll check. Can we generate 1? Can we generate 2, 3, and so on? Okay. Now let me show the code for this. Okay. So here we are starting. So the code is not very hard and all. Just you need to make sure like what was the key catch here. So we needed to convert the original array into initial stage. Initial stage is By doing modulo, we can create an array or get the initial stage of our array. So here we are taking two inputs, n and x. N is the length, x is the value with which we can increment or decrement any element of our array. This is array that we have created, and what we need is a count array. Okay, so before that, let us explain a bit more. So what we are allowed is we can add x to any element ai any number of times. Okay, what I said that I have created extreme starting array, initial array of array that is given to me. So you can take example this 1, 2, 3, 4, 5, 6. So suppose this is your original array given to you and value of x is 3 only. So what I am doing, I am doing modulo with every value. So 1 modulo 3 is 1, 2 modulo 3 is 2, 3 modulo 3 is 0, then 4 modulo 3 is, what is 4 modulo 3? Okay, 4 modulo 3 is 1, 5 modulo 3 is 2, 6 modulo 3 is 0. Okay, first we'll check if 0 is present in my array or not. If 0 is not present, then we cannot start. The basic requirement is 0 should be present in my array. So let us take 0 also to get started. Now you have array like this. So once you have array like this 0, 1, 2, 0, 1, 2, 0. So let me write it here 0, 1, 2, 0, 1, 2, 0. So this is your array. Now how we will work? I am starting from extreme 0. You using count, like I created a map with store frequency of every this element. So in that map I am storing 0 is occurring 3 times, 1 is occurring 2 times, 2 is occurring 2 times. So this information I have with me. Okay, 2 is occurring 2 times, 1 is occurring 2 times, and 0 is occurring 3 times. So this I have stored in map. Now what is happening? I'll start from 0. Okay, I want to see what is the maximum value that I can get or generate. So can I generate 0? So first I'll find its modulo with x. So 0 mod x is 0. Okay, how many values of 0 is present there? Okay, it is present. It is 3. It is greater than 0. So it means I can use this value 0 for generating this value. Okay, so I can generate this 0. So I'll decrement the count of this. So count of this will be decremented to 2. Okay, I have utilized one of these zeros. Okay, so I am saying I have used this 0 for getting this element 0. Okay, once I'm done with this, what I do is I go to next value because I can get 0. So I'm done. Now I'll try to check if I can get 1 or not. So next time I'll check for 1. Can I get 1? So let us do the modulo first. So you get 1. So in my map, 1 is occurring 2 times, which is greater than 0. So I can get 1. Okay, good. So I'll get that 1 and reduce its count because 1 is used. So this one is used. So its count is also decreased by 1. Now in next step, what is occurring? In next step, I'll try to get 2. 2 modulo 3 is 2. So this value is x. We are doing 2 modulo x only. So can I get 2? Yes, 2 is present 2 times, you can get. So let us get 1. So its frequency will be used. So I have used this 2 for getting this value. Okay. In next iteration, I'll try to find 3. I try to get 3. Is 3 present? Like, can I get 3? Yes. So 3 mod 3 will do, it comes out to be 0. Okay. Is 0 occurring? Is there any frequency left? Yes, 0 is still occurring two times. So let us use it one time for getting this 3. You can add this 3, this x in 0 and get this value. Okay. So this 0 is utilized for getting this 3. Okay. You are done. This frequency will be updated to 1 now. Now what? Now you'll check for 4. Can you get this 4 value? 4 mod 3 is 1. Okay. Is 1 occurring in your array? Yes, it is occurring one more time. So let us use this for getting 4. Because 1 plus x, which is 3, you will get 4. Okay. So you got this value. 1 you got. So you will utilize this for getting 4. Next is you will try to get 5. So 5 modulo 3 is 2. So is 2 present in your array? So you'll check in your map. Yes, it is occurring one more time. So here after this, it is updated to 0. So 1 is no more now. 2 is occurring. Yes, let us use this 2 for getting this 5. Like 2 plus 3 will give you 5. Okay. So this you will get. So you'll decrement its count becomes 0. Next iteration, you will try to get 6. So this 2 is over for 5. Now this 0, 6 mod 3 will give you 0. Is 0 present? Yes, it is present. You will use that for getting 6. So 6 is done. Now next value is 7. Can you get 7? Let me rub some space and rub and create some space. So we want to get 7. 7 modulo 3 is 1. Is 1 present? No. Now there is no more 1 left. So you cannot get this 7. So the maximum value of MEX that you can have for this array is 7. So here I gave you exact value 0, 1, 2, 3, 4, 5, 6. If you have gotten this array also, the answer for this also is 7. You got my point? So this is the extreme initial stage. So you will convert your array into this initial stage. And from there, we'll check what is the maximum value that we can get. Okay. Now let us see the code for this. Now, is it clear what count is doing? Count will store frequency of the basic values, modulo values, like values that we get after doing AI mod X. Okay. What is this set doing here? So set is a data structure which is used for storing unique characters. Why we use set? Because in set insertion, deletion, searching, operation like this are very quick. It takes over log and per query for doing all these operations. Now you can see this strategy like this is standard way of using set and count, sorry, set and map for solving this kind of problems. So what we are doing here, AI mod X, we are making a initial exact like extreme initial state of this array. We are converting to the basic stage from where we got these values. Okay. Now after that, we are taking care of their frequency. We are storing those frequencies in map, and we are also inserting this value in set. We'll see why we use this map and set both at once. Okay, because this helps a lot. Set is very useful because insertion, deletion, and searching is log of n. So we'll see in future also. You'll just give a second and you'll see why we are using set. Okay, now we will start from 0 because first, okay, this I need to check here. So one thing that we missed is we need to see if 0 is present in our array or not. If 0 is not present, then we cannot start. 0 is the basic requirement. So I need a flag for checking that. So if AI is 0, then flag equal to 1. Okay. So if there is no 0 in my array, then I cannot start. 0 is the maximum excluded value. Oh, sorry, minimum excluded value. Okay, so before starting checking for other values, we need to check. Before moving forward, 0 should be present in your array. If 0 is not present, then max is always going to be 0. You got my point? So this is the condition for that. We are using a flag here, int f equal to 0. If 0 is present in my array, then I'm marking it. Okay, then I can proceed further. Okay, if I'm proceeding here, it means 0 was present. If AI mod x is 0, then we can subtract and it is possible. So for large values, okay, so you are saying if AI mod x is 0, then we can subtract. Okay, we can add also in case like I will take example. Okay, why we need to convert into basic stage? There are some colliding examples also. We'll take that. Okay, one very colliding example is this 0, 1, 2, 3, 3. So here to get a 6, so I need to add 3 to any one of this. Okay, in that case I can get 6. But here you will see that 3 mod 3 is 0, then you'll try to decrease its value. So it will not really work. So what you can do is first, that's why we are converting into initial stage. So which is 0, 1, 2, 0, 0, 1, 2. So this is the initial stage. From this array, you can get the above array and all other arrays which are possible. So this is the starting point. We are going back to the starting point. Okay. So in this problem, we have to do that only. Now we'll start finding, getting, can we generate this max or not? So first we are finding the reminder for this start value. I want to see if I can generate this start value or not. Okay, now here comes the part where which I was talking about. What is the use of this set data structure? The use of this set data structure, we are using it to implement this find function. Find function is nothing but it search if this element is present or not. Okay, and the time complexity of this is log of n because set all operations are log of n. Searching, deleting, inserting, every operation is log of n. If this element is present, this reminder is present, it means I can get this value by adding. Okay, now what I do is if count of that element is 1, it means I can form the start value and after that there will be no value left. So this is for erasing that value. Okay. Whenever I have one element left and I am going to generate this start value. After generating, there will be no element. So I need to remove it from my set. So this is the condition for that. Okay. After that, I am reducing the frequency of these values. Okay. Because I have utilized this value for those. So what happening here is I utilized one for getting one. Next one, so I need to reduce the frequency of this. Okay. So next time I only have one left, which I can use for generating four. Okay. So I need to make sure this. Okay. Whenever I am getting some value, I need to reduce its frequency. Okay. Once I am able to generate this value, I'll try to get the next value. So start plus plus. So just basic things we have checked. So first we are checking if this value is present in my set or not. If it is present, then only I can generate this start value. If it is present, then I'll use this and also reduce the count of those values. If count becomes 0, so this is for that. So next time I cannot use, so I'll erase it from my set. Okay. And at the end, whatever start value currently possess, we are not able to generate this value. So this is the minimum excluded value and this is answer. So that was it for this problem. Now, do you all got this problem or not? Please tell me. Or you have any doubt in any part, you can tell. Okay. So this MEX problem is very repetitive. This one and the last stack problem that we discussed, that was also very repetitive. Okay. Now for this one, tell me which part you are not able to understand, or if you are able to understand, please write in chat. Yes, you are able to understand. Okay. Okay, Karthik, understand. What about others? So you guys are trying or not? Okay, try on parallel. These are very good problems. Okay, these are really, really good problems. Actual problems of online assessments. Okay, Vigneshwar also understood. What about others, guys? You have any doubt? Anyone have any doubt before we move to next problem? So next set of problems are going to be more interesting. Okay. Okay. No one have any doubt. Let us move on to next problem. So this is paint the ceiling problem. I hope this is visible. So before this, let us solve this one. Okay. So this is the next problem that we will be dealing with. So read through this problem. This is very long statement and all. So we'll cover at the end. Okay. I want you to go through this one, this short problem. Very interesting. Okay. We just saw how to use set and map and all. So this is a slight hint. We have to use these concepts here. This is a very good question. So let me highlight few things. Okay. So I hope you read the problem. Problem is a class has some number of students, let us say n number of students, each with particular area of knowledge. Okay. Or a talent. So you are given a talent array which tells you what is their talent and all, or area of knowledge, you can say. Or each talent is represented between any value from 1 to there is one upper limit talents count. Okay. The team must be formed for quiz competition. So for there is a quiz competition for which you want to form a team and must have at least one member from each of the talent. So every variety of talent you should take. Okay. Now the talent are listed in array and the students must be chosen consecutively. So it is like subarray. When you take consecutive values, we call it subarray. For each starting index, determine the minimum number of students that must be selected to have at least one member from each talent. So we are considering, so if this problem statement is like, for every index, what we have to do, we want to find or form a team which consists of every talent. And for that, we want to know minimum number of talent students that we need to take. Okay. So this is a very interesting problem. We solved a similar problem in previous session also. So I'm expecting some answers from you for this problem. Let us see how many of you are able to solve this. Okay, in some cases, so you go through this example. Okay, let me explain this example. So this is the talent array. So we'll start from the first index. What is our goal? To get every talent. Okay, and for that also, what we want? Minimum number of students we want to take. So for the whole array, number of distinct values or distinct talent is three, one, two, and three. Okay. So I am focusing on that. So if I get these three values which are occurring consecutively, I'll be good. Okay. I'm getting all type of talent and my basic condition is satisfied. So for this index, the answer is three. I can see here. Yes. For next index, if I start from this index, then I have to take 2, 3, 2, 1 to get all the talent. So I'm taking four students. So that's why answer for this is 4. You got it? Now, if you are starting from this index 3, now what is the issue here? Sorry, what is the minimum size that is possible? So you can take 3 to 1. Okay. So it is forming three students. Okay. If you take three students consecutively, you are done with all the talents. About what about these? So if you start from here, obviously number of students left is only two. From two, you cannot get three talents, so that's why minus one. And for last also it is minus one. So for last number of talent student is going to be minus one. Okay, because you are not able to generate those many talents because number of student will be less. So for this problem, how will you actually solve this? Okay, first tell me what is the worst time complexity allowed in this situation? The value of n is 10 to the power 5. Okay, for this, what is the worst time complexity that is allowed? See, the upper bound of number of operations is 10 to the power 8. If n is up to 10 to the power 5, you cannot go n square because n square will be 10 to the power 10 operations. 10 to the power 5 into 10 to the power 5. So you need to be less than n square. Okay. Now for 10 to the power 5, n log n is the worst time complexity that is allowed. So if your answer is n log n or better than that, which is O of n linear, then you are good to solve this problem. Like your approach will solve this problem. You will not get TLE. Like we have a lot of students, so why we are not getting any hints, guys? Karthik, what's your approach on this? So we have a lot of students who earlier answered. So you are facing difficulty in this? Okay, focus on this. If you start from first index, so first goal is to find the last index where you are achieving all the talents for first index. Okay. After that, what you are doing, you are shifting your start point. Okay. For first index, first you find what is the last index, not last. What is the first index where you are getting all the talents? Okay, so that is the length or that is the number of student you need to take. After that, what you're doing, you're going to next index. Now for this index, you want to find what is the length going to be minimum length when you will get all the talent. So after this, so there may be condition you need to take few more talents. So you are going like this. So I have given you enough hint for this problem. Okay, let me help you out with this. So this is a very wonderful problem. So logic, I'll talk about the logic. So what I'm saying is you are given array. So you are given an array A of length n and the values in this is going to be between 1 to there is one talent count upper limit. Let us call it y. So between 1 to y. So first task is to find how many distinct values are there in your array. So first task is to find number of distinct values in your array. Okay. Because my main goal will be to achieve this only from every index I'll start. And as soon as I get these many number of distinct indexes, I got all the talent. So I'll consider that length. Okay. So one example can be like this: 1, 1, 2, 3, 1, 2, 4, 1, 2. Something like this. So for first, let us for first index find what is the minimum length or minimum number of students that I will need for getting these many number of talents. So for this array, how many distinct elements are there? So number of distinct elements is 1, 2, 3, 4. 4. So my goal here is to get 4 distinct elements. I'm starting from first index. Okay. Now I'll keep on going. So first I got one. Okay. So one distinct element is done. Next I go to this element. This is also one. So I will not increment my count. Next I go here. I am getting a new distinct element. So my count is 2 now. Again here my count became 3. Again here 1. So 1 is already present. 2 is also already present. Okay, sorry. So okay. So here is a array. Here is a array that we are taking. So for array of length n, the value is going to be between 1 to 1 talent count value. So this is giving to you. Your array value is between that bound only. Now what is your first task? Like for every index you want to find minimum number of students you need to take consecutively to get every talent. Every talent means you need to find number of distinct elements in your array or number of distinct talents in your array. Okay. So in this case, number of distinct values or number of distinct talents is 4, which is 1, 2, 3, and 4. Okay. So I got this value. First, you will find this thing, number of distinct values. Now you will start from first index, which is index 0. You are starting from this point. Okay. Now you will try to find what is the minimum length you need to get all the distinct talents. So here, when you start from here, you are getting one talent. Okay. Now here, this is repeating talent, so count will not increment. When you go here, you are getting one more talent, so your count will change to two. Again, here, what is happening? You are getting one more talent, so your count is becoming three now. Here, what is happening? One is already present, so you will not increment your count. Here, what is happening? This 2 is already present, you have considered this, so you will not increment your count. So it will remain 3 as it is. When you reach here, you are getting a distinct talent. So your count will be updated to 4. Oh, sorry, sorry. So your count is updated to 4. It is equal to number of talent that you need. Okay, so this is the place where you have to stop. How many students you have taken? So this is, let me write index for this. So you are stopping at sixth index when you are starting for zeroth index. Okay, so number of talents here is 6 minus 0 plus 1, which is 7. So you are taking first 7 values, first 7 talent to get all the talents, all the 4 distinct talents. Okay, now for this index, the answer is 7. Okay, so let me write it somewhere. For index 0, if you start from index 0, you need to take 7 consecutive values from index 0 to get 4 talents. Okay, now what is the next scenario? I am going to this place. You got my point. I am shifting my start point. Now for this index, if I start from index 1, what is the length or how many consecutive students I need to take? So if I'm going here, I'm losing this candidate of talent 1. Okay. But since this talent is already present here and here also within the range, so it will not make any difference. So I'm moving my start point, and here I have all the talents. I can see I am having one, 2, 3, and 4. So I'm good. So this can be my end point. Okay. For this index 1. So in this case, start point is 1, end point is 6. Number of students is 6 minus 1 plus 1, which is 6 only. So here I need 6 consecutive students from index 1 for index 1. So these are the 6 consecutive students which are giving me all the 4 talents. Okay. Now what next? Again I am moving to next index. When I'm moving to next index, one is lost. So one talent, oh sorry, one student of talent 1 I'm losing. But I already have that talent present in my range. So it will not make any difference. So for this index, I have all the talents. So from index 2 to index 6, I have all the talents, all the 4 distinct talents. So in this case, number of students is going to be 5. So answer for this index is 5. Now what next? I'm going to next index. When I go to next index, I'm losing a talent 2, a student with talent 2. So when I'm losing this, is there any more 2 present here in this range? Yes. So there will be no more difference for me. Okay. For this also, my starting point is 3, my ending point is 6. Within this range, I have all the 4 variety of talents. So I need 4 students. What next? So now I have 3, 1, 2, 4, 1, and 2. So I am at this particular index. I saw that, and this is my endpoint till now. Within this range, I have all the 4 consecutive values, all the 4 distinct values of talent. I'm good. When I move in next, when I go to next index, I'm losing a talent 3. Student with talent 3. Okay, now I am here. Is There any three present in this talent group? No. Okay, so I moved to this particular index which was 4. Okay, if you see here, this one is present at index 4. So this was index 4. This is index 6. So when I go to index 4, I lost a talent 3. So I need to search for 3 here. Okay, I'll keep on going. So now I will increment my this end point. I need to get a talent 3. Okay, I need to get a student whose talent is 3. Talent value is 3. So I'll increment here. I'm getting a talent 1. It is not 3. So again, I need to increment again. It will keep on going until I found a talent with value 3. Okay. So in this way, you have to move. So this is basically a two-pointer problem. Two-pointer problem where you need to see in your range all the distinct values are present or not. And in earlier problem, we used set data structure and map data structure. Okay, for similar things. What we are doing here, I am going from index I to I plus 1. So while going, what I am doing, I am losing a candidate of this talent. So in this case, with the help of map, I can decrement the count. So count of this talent I minus minus. If this count of talent becomes 0, it means I lost a talent. So I need to erase from my set also. Okay, I'll erase from my set this talent I. Okay, so when I'm moving from I to I plus 1, if this talent count is 1, it means I will lose it. Okay, there is some endpoint which I'll find for first index, and after that, we need to keep on moving. Okay, so when I'm going from I to I plus 1, these changes I'm doing. I'm reducing count of this talent I because I'm losing. I'm going ahead of it. And if the count becomes 0, I'm erasing also. So when I go to this point, if number of distinct talent is not equal to x, what was x? X was total number of distinct talent in my whole array. If this is not happening, it means I lost this I talent. I will keep on finding in further students. Okay. So here is the endpoint. I will keep on upgrading it. Going to next student, checking if the talent of this student is equal to talent of I student or not. Because I lost this talent. Okay, the place where I will find, I will stop there. And the length going to be answer for this I plus 1 index. Okay, so I will go in this order. So what I am saying is, let me code it down for you. Okay, now is my ID visible? I'm sharing a ID. So it is C++ ID. Is it visible or not? Okay. So what I'm saying first we need to see take n. What is n? N is the number of students that going to be or talent you can say. Now there need to be an array of talents. Okay, so you can use a set also for finding unique talents. So first, what I need to find is total number of unique talent in my whole array. Okay, so in X, I'm storing total number of unique talents. So if you return the size of your set, because set is a data structure which contains only unique values. Okay, so in X, what we have? we have number of unique talents in our whole array. Now I need an answer array also, which will store answer for all the indexes. And at the end, I have to print that only. Okay, those who are facing like difficulty using some other language, don't panic. I am explaining line by line, and I will provide code also. You can using Chat GPT, you can convert the code to your own language. Okay, so don't panic. Just understand the logic first here. So what I am doing here? So for first index, what is the last? Smallest index, the smallest set of students, number of students that we need to take so that we are having X talents. Okay. So for this, what I said, we need two things. Map we need for finding frequency of students so that before whom to remove, whom to not, we'll take care of that using this. So there need to be two things. What's my current index is I, and what is my endpoint. Okay. So for first index, I am finding this endpoint. Endpoint is a place where I am getting all the talents for the first time. Okay. So while one, so what I'll do, I'll get this talent. So UNQ, oh, okay. So this is UNQ2 because I already used it here. Dot insert this current talent, which is A of I, and count of this UNQ2 dot size, count of this AI plus plus. So this map will store which talent has occurred how many times in our range. Okay, so for first index we are finding this end. Okay, then after that our whole condition will be to shift it. Okay, to right. Now when to stop? When my size it becomes equal to X. Okay, when number of unique elements is equal to X. What is X? Total number of unique elements in my array. When this is equal, I am coming out of the loop. Okay, else I am doing I plus plus. I'll go to next element, take that talent. Okay, now what is the number of students that I have taken till now? So answer. Okay, so I need J. So I'm moving J here. And for ith index, ith is my starting index. So answer of I is equal to J minus I plus 1. What is this J index? So J is basically end you can say. So J is acting as end. So no need of this end. J is the last index where I got all the talents. Okay. Now answer of I is equal to J minus I plus 1. So J is the last index where I stopped or where I got all the talents. Okay. Now for all other indexes, so my I is already updated now, I plus plus. I should be less than n and plus plus I. So for all other indexes, I'll find this. What is the length required? Okay. Since I'm moving to next index, because for current index I have already found how many students I need. Okay. Now for this, what is the number of students that I need? Before that, I left the last talent. So I lost the last talent. So last talent is lost. So I'll check if this talent was unique. So if count of A of I minus 1 was 1. So it means this talent was occurring for only one time in the whole range. So if I'll go from there, I'll lose that range. So if I am losing it, I need to erase it from this also. Number of unique elements category. Okay, and I need to decrement its count also. After that, what I have to do, I have to check if current set of students that are present have enough talent or not. If unique 2 dot size is equals to x value or not. If I have enough number of talent, then I'll update my answer of I, which is equal to j minus I plus 1. Okay, I have enough talent. If I don't have enough talent, I need to get enough talent. So else what I have to do? I have to get other talents. So while j is less than n, and I'll get that talent. So unq dot to insert that value. I'll also increment the count. Okay, now if this size is equal to x, then obviously I got enough talent. Okay, I'll come out of the loop. Else I need to do j plus plus. Okay, get more talent. So what I'm doing here is, so is this part clear? So here I'm removing the last value. Okay, if this value was unique, I also need to erase it from my set. If this value was not unique, it is already present in range from I plus 1 to end, then I don't need to remove. If this value was unique, I need to erase it. Okay, after erasing, I also need to reduce the count of that value in range. If unique value size is equal to x, means I have x number of unique talents. It means j is my endpoint, I is my current point, and this is the number of talent that I have taken. If this is not happening, then I will get other students and other talents. Okay. Now for this answer of I is equal to j minus I plus 1. Okay. Now here you need to check it once more. If unq dot size is equal to x or not, then only you will do this. If it is not equal, it means in there is no way you are going to get all the talent. So you can come out of the loop if this condition is satisfied, or your j is equal to n. Okay, you are keep incrementing the talents. Now you have exhausted all the talents and you have not gotten unique talents, all the unique talents. Okay, so that is the also condition you can come out of the loop. So you need to check if number of talent is equal to x or not. If it is equal to x, then you need to update. Else your answer of I is going to be minus 1. There is no way you are going to get that. Okay. Now you will run a loop. Okay. Now here we are running a loop. Now every time what we are doing, if it is not equal, j is less than n. Okay. So this will cover everything. So this is it for this problem. So what we did is, so we started with here. We found number of unique values. Okay. Then for the first index, we found the last index, which is j, where we are getting all the elements, all the talents. So this is the loop for that. Okay, and number of talent that we have taken for first student, or sorry, first index is this much. Okay, after that for all other index, if I'm going to next index, I will do this. I will decrement the count. Okay, and on decrementing, if I'm losing a talent, I need to erase it from my set also. So I'm doing that. After doing all this, if my set is having enough number of talents, then great. Okay. So I can consider J to be my endpoint and number of students can be this much. If they are not enough, I need to take more talent. So more talent means getting the J talent and then J plus 1 and so on until I get X number of talents. Okay. So this is the while loop for that. Once I'm coming out of the while loop, if number of talent is equal to X, it means I have enough talent. If it is not equal to X, it means I cannot get it. Okay. So in this way, I'll generate all the answers for every index. Okay. Now, do anyone have any doubt with this? Please tell me, do anyone have any doubt with this? Okay. So we are ending the session here only. Okay. For more session updates and all, you can join our Telegram group. So link will be shared in the chat and all. So tomorrow we are organizing two events. So two sessions all are free. One is for aptitude and all for Goldman Sachs, and second is for DSA like Atlassian pre-assessment. Sorry, online assessment session like this only. That is going to be the third session in this series. So to get updated with all that and get details of all the questions that we have discussed today, so you can join our Telegram group. Okay, you'll get the recording also. And we are ending the session here.